Welcome back. We've learned about ownership and moves, and we've seen how copy types work, but there's still a problem we need to solve. How can we use a value in multiple places without giving up ownership? Today, we're diving into one of Rust's most powerful features, borrowing. Let's start by looking at a real problem. Say we create a string and then call a function that needs to use it. We pass the string to the function and ownership moves. The function now owns the string. So what happens when we try to use the original variable after the function call? We get an error. The variable was moved. It's no longer valid. This is frustrating. We just wanted to look at the string. We didn't want to give it away forever. There has to be a better way. And there is. Rust gives us references. A reference allows you to use a value without taking ownership. Think of it like borrowing a book from a library. You get to read it, but you don't own it. You have to give it back. Look at this. We pass a reference to the function instead of the value itself. Notice that ampersand symbol. That creates a reference. Now, when we try to use the original variable afterward, it works. The variable is still valid because we never gave up ownership. We just let the function borrow it for a moment. Let's visualize what's happening in memory. Here's our owner variable setting on the stack. It owns the string data on the heap. There's a clear ownership arrow connecting them. Now, we create a reference, a borrow. This new variable also points to the same data, but notice something important. The original owner still owns the data. The borrow is just visiting. Both can access the data at the same time because the borrow doesn't take ownership away. This is the core idea of borrowing. Multiple parts of your code can look at the same data without fighting over who owns it. Rust actually has two kinds of references, and understanding the difference between them is essential. First, we have immutable references. The syntax is just an ampersand followed by the type. These are read-only references. You can have as many of them as you want, all looking at the same data. But none of them can change that data. They're observers. Then we have mutable references. The syntax is ampersand mute. These references can both read and write. They can change the data. But here's the catch. You can only have one mutable reference at a time. Just one. No others allowed. This brings us to the core rule of borrowing, the rule that makes everything else make sense. At any given time, you can have either one mutable reference or any number of immutable references, either one writer or many readers, but never both at the same time. Why does Rust enforce this rule? Because it prevents data races at compile time. A data race happens when two parts of your code try to access the same data at the same time, and at least one of them is writing. That's a recipe for bugs. Rust's borrowing rules make data races impossible. The compiler won't even let you write code that could have a data race. Let's see this rule in action. Here's a valid example. We create a string, then create two immutable references to it. Both are fine. Both can coexist. They're just readers. Nobody's trying to change anything. Now, here's an invalid example. We create a mutable string, then create an immutable reference to it. So far, so good. But then we try to create a mutable reference while the immutable reference still exists. Error. The compiler rejects this code. You can't mix immutable and mutable borrows. It's either many readers or one writer, not both. This enforcement happens through a part of the Rust compiler called the borrow checker. The borrow checker analyzes your code and enforces these borrowing rules at compile time. Before your code ever runs, the borrow checker has already verified that you're not breaking the rules. This is Rust's secret weapon. It prevents entire classes of memory bugs before your code ever runs. No null pointer dereferences, no use after free errors, no data races. The borrow checker catches them all. Let's bring it together. References let you use values without taking ownership. Immutable references are for reading only, and you can have as many of them as you want, all looking at the same data. But none of them can change that data. They're observers. Then we have mutable references. These references can both read and write. They can change the data. But here's the catch. You can only have one mutable reference at a time. Just one. No others allowed. Next time, we'll go deeper into the distinction between mutable and immutable borrows, and we'll explore some more complex scenarios. See you then.